He's made his career actually buying, selling fossils, meteorites, minerals, and done very well at it. For 28 years, let's see, he built, managed, and purchased for 7 stores selling jewelry in Las Vegas and in China. And then, fortunately then for us, he decided to make a career move and came to Jackson 4 years ago and opened the By Nature Gallery. Doug has 16 individual diplomas and 2 graduate degrees in gemology from the Gemological Institute of America. So please join me in welcoming Doug for tonight's talk on meteorites.
Can you hear me? Awesome. Well, hello. How's everybody tonight? Well, considering we couldn't get the table set up, I think everybody likes our meteorites. So I'm going to take you through a little bit of everything that has to do with meteorites tonight. If we get really, really in-depth, I think we can have you out by Christmas. So we'll probably just touch over a lot of important things, give you a good overview, the basics of meteorites, what a meteorite is, how to tell if a meteorite is real, is fake, is just a terrestrial rock, and by the time you leave here, hopefully you'll have a greater understanding of my personal love. I've been a meteorite nut for many, many years, and I'm always fascinated by them. I never get tired of them. You could have a particular meteorite from a particular fall and have 1,000 specimens, and every one of them is completely different. So you never get bored. You never see the same thing twice. And I don't get bored anymore. So welcome. So fallen stars, all about meteorites. What is a meteorite? Basically, a meteorite is a rock, an item that's come from outer space. Generally, it's from cores of planets that have exploded over the years. It's from comets caused by asteroids. You're going to see moon rock tonight, Mars rocks, and these are all things that have no terrestrial being. There are specific things about these meteorites that you will not find in earthbound rocks. Fall versus find. Big, big difference here. When somebody watches a meteorite, when you see a shooting star at night, if that shooting star actually makes it and has landfall, and you've actually witnessed it, that is considered a fall. If you're digging in your backyard and you dig up a piece of metal that you think is metal, turns out to be a meteorite, that is a find. What is the big, big difference? Provenance. Whenever you have provenance, value goes up drastically. We got to see, and we'll talk more about it in a little while, but this year in Russia in February, we had the most videoed, the most photographed, the most experienced meteorite fall in the history of our creation. More people have documented this fall. Video, we'll see a short little video on it, with photographs, with chemtrails, with flames still in the sky from this meteorite fall. So that particular meteorite, I brought a few specimens of that to show you as well. What you're going to see happen here, they're very expensive already, but they're going to keep appreciating value over and over and over again. The fall. Most meteoroids disintegrate when entering Earth's atmosphere. Only 5 or 6 of them a year actually make it to where somebody can collect it. So it truly is one of the rarest items on the face of the earth. We think gold is really expensive. It had $1,700 an ounce. Some meteorites will cost you $1,000 a gram. So they're extremely rare. Fall facts. Fall is broken down by category. There's 3 different types of meteorites, and we're going to discuss those in a little bit. But to give you a little idea of percentages, there's stony irons, which are an iron meteorite that have silicates with them, like an olivine crystal. account for only 1% of all falls. Again, a fall is something that is physically witnessed by somebody and documented. Iron nickel is only 4.4%, 49 instances of that. The Stony meteorites, which look almost terrestrial, and we'll talk about that a little bit later, of what differentiates them. 1,042 of those for 94.6% of all falls. Meteors enter the atmosphere at speeds ranging from 25,000 miles an hour to 160,000 miles an hour. Can you imagine that? You know, even at the low end, it's almost unfathomable how fast these things are moving. Fine facts. Fine's broken down by category. Stony irons, 1.6% or 8,600 kilograms. Iron nickels account for 18.6% of fines, 435,000 kilograms. And stony meteorites at 79.8% or 8,300 kilograms. The big number that looks way out of whack is the iron meteorites. The weight dwarfs the rest of these guys, even though stonies make up almost 80% of all of the fines. Again, a fine, you dig it up in your yard, you find it, that's a fine. The reason being, iron nickels are the most dense material that we know. So it's very, very heavy. I have some examples of that. When we talk about them, I'll actually have some of my folks walk around and let you feel them and touch them as I talk. Okay? Strewn field. The term strewn field indicates the area where meteorites from a single fall are dispersed. Now, in the case of the Russian meteorite that just fell, when you hear the video, you actually will hear several explosions as that meteorite continued to break up over the sky. So every time it explodes, it creates a new strewn field. This example here, all the red dots are where all fragments of this particular meteorite were found. Generally, it's in an oval pattern. There are two different types of strewn fields. You can have a mid-air fragmentation, which is what happened in Russia. Meteorites coming in, it explodes mid-air. With that, you have more of an oval path. With impact fragmentation, that's when a meteorite actually strikes the ground, explodes, and again creates a field of destruction. In the case of Russia, if that meteorite had hit the ground, you might as well say goodbye to Russia. It had a power of 20 Hiroshima nuclear bombs. That's how powerful that meteorite was when it exploded overhead. So if it had hit ground, it would have decimated most of Russia. Impact craters. Here's an example. Let's do every 1,000 years. You have a megaton explosion from an impact from a meteorite, 10 to 100 megatons. And that is enough to destroy most big cities. Every 250,000 years, 100,000 to 1,000,000 megaton explosion from an impact. Absolutely devastating. It would destroy countries, states with a single explosion. With that, you also would have destruction completely earthwide. It could be a life-ending event for everybody because of the dust cloud that's put up. Here are some of the most famous of the craters. This one is a meteor crater in Arizona. Has anybody ever been there? It's amazing, isn't it? I have pictures further on when we talk about those meteorites where there's a gal standing on the edge of this thing. And this facility here is offices, it's labs, it's everything else. And then the little dot in the bottom is another little lab that they have set up in the bottom of the crater. 49,000 years ago, measures 3/4 of a mile across, 575 feet deep. This one, Lake Basuntwi, whatever that is, in Ghana, is 1.3 million years ago. And it was so large, it's 6 miles across, filled with water, and it's now a lake. Australia, 142 million years ago, 15 miles across, 16,000 feet deep. That's in central Australia. These were all pretty much life-changing for anything within, 3,000 miles or so. Clearwater Lakes, Canada, this one's really cool. This was an asteroid pair that hit, and it created 2 different craters that formed into 2 different lakes. One of them measures 20 miles across, the other is almost 14 miles across. This guy is probably the most famous in Mexico. This is the crater, this was the meteorite fall that is thought to have put dinosaurs to extinction. So this was a very big, and that's a whole other conversation for another day on whether or not we think that happened, but this is the one in question that everybody talks about. 65 million years ago, 105 miles across in this crater. So those of you that have been to a meteor crater, how many of those could you fit in this crater? I mean, it's mind-blowing. Meteorite characteristics. Fusion crust. These are all things that, I get and my staff gets almost daily anymore. People bring in samples for us to look at that they think are meteorites. 99% of those turn out not to be meteorites. But a few things that we look for is a fusion crust. And basically that is the outer surface of the meteorite gets a thin shell where it actually melts and makes it smooth. You can see the inner part of the meteorite here and that thin, dark, almost burned up shell on it. Regmaglyphs, which we will call thumbprints, are the most common things that you see. They're very spherical, very, very smooth to the touch. Once you see one, and again, we'll pass it. Joe, you want to maybe pass one of those? Walk around with one? Let people feel them? Once you see one, you very rarely will ever not distinguish it again. They're very, very specific, very, very unique to meteorites. Iron, nickel, metal. All meteorites, with the exception of a few special ones like Lunars and Martians, are going to have metal in them. They're going to have iron and nickel. Nickel content in these meteorites is so high, there isn't a natural rock on Earth that has nickel content that high. That is one of the distinguishing factors of whether a meteorite is a meteorite. Density. Density is how heavy a rock is compared to, say, a terrestrial rock. Iron meteorites are 3.5 times as heavy as ordinary Earth rocks of the same size. Stony meteorites are about 1.5 times. If you want to take, hey Kel, why don't you take one of maybe that Gibeon, the larger Gibeon? That was the rust colored. And this Gibeon that we're going to pass around is actually very, very cool. It looks like it's rusted, which is a big problem with meteorites because of the iron content. But that is actually all the natural fusion crust on that meteorite. Extremely rare, and it has a huge, huge thumbprint in the center of it that is hard to mistake. Magnetism. All meteorites, with the exception of the Lunars and the Martian, are going to have magnetism. There's metal flecks throughout those stones. Even when they look like terrestrial rocks, they have little flecks within them that will be magnetic. Basically, any Earth magnet that you use will stick to these meteorites. I brought a bunch of small stonies that look like rocks you would just kick on the side of the road, and you put it to a magnet and it pulls it right on up. And chondrules. Sarah, would you like to pass around the chondrule? This one's a very good one. Chondrules are only found in meteorites. These are some of the original formation of our existence, of the universe. They're from nebulae, and they're small little circular granules that are very, very small, but very, very prominent. There's no terrestrial rock on this planet that has chondrules. It only comes from space. Meteorite classifications. We're not even going to go close. This makes the periodic chart look like the ABCs. And what you see is already gibberish, but then you start adding numbers to all of these letters. And this will be for another time for when we have a lot of time. But I just thought you should see it because it is a very, very complicated process. They use isotopes, chemistry, all combinations of all the above to come up with these classifications. And they do get extremely complicated. 3 categories of meteorites. We've got the Stonies, which is up here. Stony meteorites are going to look like most terrestrial rocks in most cases. The iron nickels are going to be extremely heavy, extremely dense. Again, you're going to see all those little thumbprints throughout on the majority of them. Stony irons are going to be your iron meteorites with olivine crystals. And I've got one set up over here when we get the lights off again. You'll see how beautiful those olivine crystals are. They actually cut these out now and make jewelry out of them. Quite expensive. So who's born in August? It's your birthstone. It's olivine, yeah? Stony meteorites are the largest group of meteorites. They were part of the outer crust of a planet or an asteroid. And you can see here, this one would have been a unweathered fall. So like the pieces from Russia, we watch it come down, we collect the pieces very, very quickly. They don't have time to weather. So with that, you have a beautiful white interior, a real bright interior, and then that dark fusion crust on the outside. 80+ of all meteorites are stony meteorites. Those are the most common that you're going to see. Stony compositions. Chondrites, we spoke about that. Thought to be 4.5 billion years old. They are the most primitive rock that we know today. Their composition is silicate minerals like olivine, plagioclase feldspars. Metallic nickel iron occurs varying percentages and is accompanied by iron sulfide minerals. When you slice these guys up, and Sarah, my daughter there in the purple, is passing one of those around, you can actually see the little chondrules, and you can see some metal flecks in there as well. These meteorites look most like Earth rocks. This is what, again, you kick it on the side of the road, your neighbor picks it up and gets $1 million for the little rock that you kicked. Because they're very, very hard to tell. Chondrules. Some stone meteorites contain small, colorful, grain-like inclusions known as chondrules. These tiny grains originated in the solar nebula and therefore predate the formation of our planet and the rest of the solar system. This is a really great photo of chondrules. Fusion crust. Again, it's that burned up shell that we find. Just some pictures of some chondrules. Another stony. And again, this piece, if you put a magnet to it, if you put an earth magnet to it, it's going to stick to it. Most people, they look at these, and when I show you some, take some of the NWAs, the small ones with the magnet, and you look at these rocks and you go, there's no way these are going to be magnetic. And they'll stick right to that magnet. There's Jill. Just some different stony conditions, some that are broken, some that are weathered, some that actually do have some thumbprints. Special stony meteorites. You've got your lunars and your Martian meteorites. Again, these won't have the metal flecks. These are achondrites. They're lacking chondrules. They're lacking the metal flecks. Lunar meteorite, 1982, John Shute led an expedition in Antarctica, probably one of the most famous meteorites ever. The Allen Hills 81005, this is a photo of it. When he found this thing, he looked at it and said, this looks awfully familiar to something that we found on the moon. Well, it actually is a part of the moon. Lunar facts, lunar meteorite is a meteorite that is known to have originated on the moon. So how do we get it? You know, you can go up if you're an astronaut. We have a NASA guy here today. Where is he at? Is he still here? I think he left. He was running right. But he actually helps put spacecraft on the moon for NASA. And so those are available, but it's illegal for us to have them. So how do we get our meteorite? An asteroid or a comet hits the moon, compresses the moon dust, the moon rock that's on the surface. It breaks off, eventually makes it through our atmosphere, and hits the Earth like a regular meteorite would. Only about 100 of these are known to exist. We have a few. I have a slice to show you today, and after we're done, anybody that wants to come up will even let you touch the moon. It's probably the only time you'll ever get to do that. Most lunar meteorites are launched from the moon by impacts making lunar craters a few kilometers in diameter or less. Most lunar meteorites are a more comprehensive sampling of the moon. And that is because when you find a moon rock, you generally are getting one type of rock. When a comet or an asteroid hits the moon and compresses all that dust, you're getting samples of a lot of different rocks that have been crushed and weathered over billions and billions of years. So you're getting a much better sampling of what the moon actually is. Rare lunar meteorites can fetch up to 1,000 a gram. I've got a piece that is yay big, and it's $50,000. But it's a nice one. These are some examples of some of the lunar meteorites. I brought you a slice very much like this, and I brought also an end piece. It's called an end cut, where we actually have the outer crust of the meteorite and also it's sliced so you can see the internal. Martian meteorites. January 3, 2013, NASA reported that a meteorite named NWA 7034, nicknamed Black Beauty, found in the Sahara Desert. They called it Black Beauty. This thing has more water in it, 10 times the water that's been found in any other Martian meteorite. This, of course, is a photo of Black Beauty. The meteorite was determined to have formed 2.1 billion years ago during the Amazonian geological period on Mars.
How do they know it was from Mars?
We have a Mars rover. And the Mars rover takes samples of all the soil and a lot of the rocks that are on Mars. So we now can compare that data to what we have on these guys. Same with the moon. Same with the lunar. Only about 30 Martian meteorites are known to exist. And when I say 30, that doesn't mean 30 pieces. That means 30 finds or falls. Martian meteorite is a rock that formed on the planet Mars, was ejected from Mars by the impact of an asteroid or a comet. The majority of Martian meteorites are quite young compared to most other meteorites, and seem to imply that the volcanic activity was present on Mars only a few 100 million years ago. That's something I'm doing.
It's doing something.
Am I on the timer already?
No.
That's exactly
Examples of Martian meteorites. I have a slice bigger than this that I brought to show you tonight. And they're very, very cool. It's a very, very thin slice, so I'm not going to let you touch that one. It's really, really, it's like $18,000 and it's a sliver. Iron nickel meteorites. These guys are what most people think of when they think about meteorites. Iron meteorites were once part of the core of a long-vanished planet or a large asteroid and are believed to have originated with the asteroid belt between Mars and Jupiter. They're among the densest materials on Earth and will stick very strongly with a powerful magnet. Joe, take the magnet and click it to the Sim Chan slice and just listen to this. You don't even need the microphone.
Are these the Vestas?
Yes, yes. And so with these meteorites, you're talking on average 97% of iron and nickel, most of it being iron, of course. That's why they're very, very magnetic. Iron nickel composition. In most specimens in this group, the iron content is approximately 90 to 95%, but the remainder comprised of nickel and trace elements. Each variety of meteorite will have different concentrations of elements. So you may have some that are 20% nickel, you may have some that are 5% nickel. Those percentages are still greater than any terrestrial rock that we know of today on Earth. Other trace elements, germanium, arsenic, antimony, copper, chromium, molybdenum, silver, indium, iridium, palladium, cobalt, platinum, gold, sulfur, phosphorus. There's a lot of varied trace, and these things are like 0.33 parts per million, so it's very, very, very trace. The Widmanstatten pattern, this is one of the funnier things with meteorites. Just saying Widmanstatten. Most people look at you like you're nuts. But these are a pattern that are on a meteorite that are only found on meteorites. There is not a terrestrial rock that we know of that has a pattern that is natural like this. Basically how it happens is you slice the meteorite and you have to acid wash it to show this crystalline structure of nickel. And the varied nickels, they say it takes 1,000 years to cool this nickel enough to change it 1 degree Celsius. So it's actually the cooling process of the nickel that causes these striations in the meteorite. A couple different types here. The other interesting fact about the Widmanstatten is particular meteorite from a particular fall will have the same type of pattern. It'll be a different pattern, but the texturing, the thickness of them will all be the same. Yet every different fall has its own, almost its own fingerprint of pattern. And then we have the Stony irons. These, besides the Lunar and the Martian, are the rarest of all the meteorites. These are the ones that have your basic iron nickel meteorite, and then the olivine crystals stuck within. I brought 3 or 4 different ones to show you, and a lot of times they'll also have the Widman pattern, because if they acid wash it, the iron part of the meteorite does exhibit that pattern. Stony iron composition. Stony iron meteorites are meteorites that consist of nearly equal parts of meteoritic iron and silicate. The iron, again, is very, very similar to just an iron nickel with the addition of the olivine. Also called a palisite meteorite. Palisite meteorites are another name for stony iron. Palisites are among the rarest and most beautiful. The larger piece that I've got back there, and Joe, you can hold it up if you like. This one slice that's fairly thin is $15,000.
Wow.
Meteor wrongs. This is the fun part. 99% of what people think are meteorites actually are not meteorites, they're terrestrial rocks. Some of the characteristics of the wrongs. Round or spherical shape. Meteorites almost never are perfectly round. They're smooth, they're roundish, you don't generally have sharp edges, but they are very rarely are they ever like a marble or a ball. Bubbles or holes. The outer portion of a meteorite, the fusion crust, is either smooth or has the characteristic thumbprints. Many terrestrial igneous rocks are porous and have holes in them. These holes or vesicles were produced by bubbles of gas that formed in the magma as it was erupted. If you find a rock that is porous or contains vesicles, it is definitely a terrestrial rock. You won't see it in a meteorite. And crystals. If you see quartz, 100% meteor rock. Hot or radioactive. This is the one that most people think, and in our gallery, most people that are looking at meteorites, the first thing they ask me, is it radioactive? Never is it radioactive. The streak. The gentleman, who was I talking to earlier? The other year. You know, if you take a ceramic tile, you flip it upside down to the rough end. If you rub what you think is a meteorite on that, if it leaves a streak, 99% of the time it is not a meteorite. If it is a heavily weathered meteorite, it is possible you will have a faint streak, but it's extremely rare that that happens. Other kinds of metal. Human activity has produced objects made from pure iron for centuries. So it's possible to confuse lumps of man-made iron with meteoritic materials. We get a lot of iron slag. in the gallery. And one of the easiest ways to tell is the shaping of it. When you see meteorites, when you're around meteorites, you get to know the feel, you get to know the density, you get to know all that stuff. And when you hold something that's man-made, your gut tells you almost immediately that it's not. And then we do some small tests here or there to verify that. Obviously, if you have iron slag, it's going to be extremely magnetic. So that test is worthless to you. There are other tests, and we'll get to that in just a moment. Magnetism. 90%, 99% of all meteorites are attracted to a strong magnet. That does not look like a very strong magnet. But Earth magnets are generally what you want to use. They're the strongest, and they, even on our little NWAs at our Northwest Africa pieces, it does attract to them very, very quickly. The streak test. If you give a vivid red to a brown streak, it's going to be hematite. Our biggest, guys, why don't you pass around some of the hematite nodules? These are nodules that were found on my sister's property in Texas, out in the middle of nowhere. Does anybody know where Graham, Texas is? I didn't think so. It is out in the middle of nowhere. And these interesting nodules, the property is filthy. It's dusty, it's dirty, and these things are on the surface pretty much the way that Kelly and Joe are showing them to you right now. No dust on them, no dirt on them, no crud, no mud. It's like they just were sitting on the top of the ground, and I thought for sure they were meteorites when we first found them. I sent one to UCLA, and they put it under an electromagnet, and there was absolutely zero magnetism. So if you take this guy and you rub it on ceramic tile, now I know, it gives you a red to brownish streak. One of the other substances we get a lot is magnetite. Magnetite is going to give you a black-gray, almost like a leaded pencil look. And then the window test. If it has magnetism, if it doesn't have a streak, you're a lot closer than you were before you started. The next thing is to do a window test. You basically take a file, rub a little bit of the end of the meteorite off, and you can see the little metal flecks that are in there. That gets you one step even closer. Doesn't mean 100% that it's a meteorite, but it does get you closer. If you get to this point, your chances are very, very good that you have a meteorite. Let's talk about some of the most famous of meteorites. The Campo del Cielo out of Argentina, Gimpian, Northwest Africa, Sikhote-Alin, Muonionalusta, Diablo, Chelyabinsk, Simchen, Brenham, Kansas, Henbury, Australia, and Nantan, China. I have specimens of every one of these to show you tonight. So when we're done, you're welcome to come up. We'll show them to you. You can touch them, feel them. You can even buy them if you want. No, I'm just joking. We're not. Campo del Cielo, Argentina. Northern part of Argentina, as you can see here. This meteorite fell between 4,000 and 5,000 years ago. It was actually found in 1576. Total known weight is 100 tons. This was a big meteorite. Again, this was a life changer for anything that was in, maybe a couple thousand miles out when it hit. The core of this meteorite, when this thing impacted, the core was embedded into the ground. It then exploded into different pieces, created a strewn field. The core of this meteorite is still in the ground. The government, a couple of years ago, gave a permit to pull it out of the ground. The core of this meteorite is 25 feet in diameter and weighs 35 tons. What do you do with that when you pull it out? I'd like to have it, but what do you do with it? Composition, heavy iron, moderate nickel, and cobalt. Here's a piece of it. I've got several varieties of it over there for you to look at. Big thumbprints on these guys. The thing to watch out for the Campos, if you decide you want to buy one for yourself, it's really enticing to go onto eBay and buy one that seems really heavy for very little money. Well, this particular meteorite had a strewn field that was over 100 miles long. So part of it landed in a swamp, part of it landed in a desert. What do you think happens to the ones that landed in the swamp? Put them in your drawer, open it up in a year, and you're going to have about 5 different meteorites because it's going to crumble on you. What happens is you have moisture that is inside these things, and as they internally rust, they actually just crumble on you. So you have to be very, very careful.
What makes the thumbprints on them? How do those form?
In space, when it's cooling, it's heating, it's pressures, it's heats, it's the elements get very volatile in the heating process and the cooling process, and that's what causes them. This is the crater for the Kempo. Gibeon in Namibia. So it's kind of hard to see, sorry. Right here, the Namib Desert. 92% iron, again, fairly moderate nickel at almost 8%. You got phosphorus, iridium, germanium, a little bit of everything in this guy. The fall was prehistoric times, found in 1838, 26,000 kilograms is the total known weight of this guy. I have 2 exceptional specimens to show you tonight. Very, very large thumbprints on them. That's a nice one. Here's a couple that have been sliced. All of your iron meteorites, when you slice them and acid wash them, they're all going to have the Widmanstatten. But again, they're all kind of have their own little look to them. NWA, Northwest Africa. In doing a lot of research to try to figure out total known weights and such, it's very difficult because these are fairly new finds. 2001 was a huge one. You could see these kids piling these things up. I go to the shows, and there's buckets after buckets after buckets of these meteorites. There are a lot of them. And each one is classified in its own way. So I chose NWA 3009. This one was found in 2001. Nobody has any idea at this point of when it fell. They have no idea. Total known weight of this particular one is 1.5 kilograms. This guy at 1.5 kilograms will be very expensive to have because it's very rare, there's little of it. Okay? Nice piece of it. So this guy here, when it was found, it had to have been a recent fall because it isn't weathered. That's what gives you, again, that bright color on the inside of it. This one shows a really nice Chondrules. Sikhote-Alin, Russia. Russia has a lot of meteorite falls. This was a big one in 1947. It was a witness fall. It was heavily documented. The National Museum of Russia actually witnessed the fall, collected a lot of the meteorites. We actually sold the largest piece of Sikhote-Alin outside the Russian museum. It was bought from the museum 2 years ago. I think it was almost 300 pounds. 93% iron, 6% nickel, some cobalt, phosphorus, and sulfur. Total known weight is 30 tons. Beautiful, beautiful thumbprints on these guys. Sikhote-Alin, when this thing hit, it was in a forest. So you're going to see 2 different types. Now, did we bring the diffusion crust Sikhote, the little one? We did not? Is that your fault or mine? That was mine. We should have brought that one. It's a little one, but it's got the fusion crust, which is really, really cool. A lot of these meteorites that you see actually are, do you have the shrapnel there? We'll pass around a couple pieces of shrapnel. When this thing exploded in the forest, pieces of it were embedded in the bark of the tree. So a lot of them are really, really uniquely shaped, and you look at it, somebody melted that. It isn't. They actually pulled them out of the trees in the forest. You see all the unique shapes. And again, that's formed from bark. Has anybody ever done any jewelry making? Do you ever do gold nuggets?
No.
When you make a gold nugget, you take an old bristle broom with wicker, I guess, the old brooms, and you cut them and you tie the bristles together and you pour the gold into it. And then the gold seeps through all this wicker and creates a nugget style. And that's exactly how these things were naturally in the bark of the tree. And this is extremely rare. When you have a meteorite that actually has a hole going through it. You just don't see that very often. There's one in Canyon in Meteor Crater, and those that went there probably saw the hole in the meteorite. Did you guys see that when you went? No? Maybe? Don't remember? Very, very cool. It's a huge meteorite, and it has a hole about this big through the center, and it's just natural. Just very rarely does it ever happen. Muonionalusta out of Sweden. This was a fall in 1906, and quite high on the nickel, 8.4%. Again, the iron's pretty common. They think this thing fell about 1 million years ago. One thing about the Muonionalusta is out of Sweden, the Widmanstatten patterns are gorgeous. You see a lot of jewelry made out of these guys because the pattern is so faint that yet it almost looks like an artist sat there and completely etched it out themselves. They're really beautiful meteorites. The cubes, I've sold a bunch of those. That's our transformer cube. A big piece being dug out of the ground there. Canyon, Diablo, Arizona. 7% nickel and 80 parts per million gallium. You've got 320 parts per million of germanium, iridium. This guy's got a little bit of everything. 49,000 years ago. It was found in 1891. Again, 30 tons of meteorite there. If you ever drive by and you can see this meteor crater, I promise you it's unbelievable. When you get up there and you stand on the rim of it, it's hard to fathom that that came from space and was a single impact. It's incredible. There's the lady standing on the edge of the rim.
How big was the rock? I don't get a sense of how big the object was.
A piece like that is going to be probably in the neighborhood of the size of a Volkswagen.
And that's what made it.
That's what made that. It's coming in very, very fast. It's very, very powerful. Remember, the one in Russia was like 20 Hiroshimas, and it didn't hit. If it would have hit, it would have been devastating. Here it is, the Chelyabinsk, Russia. Witness fall February 15, 2013. Gorgeous, gorgeous interior on these guys. Total weight, total known weight, yet to be determined. When this article was written, 57 fragments were found. There have been a lot more since then. You can see how close it is to Moscow. By Moscow to here. Truly. Another piece of it. Video is going to play maybe next, maybe another slide. It will have explosions in there. It might be a little loud. I don't know how loud the sound system is. So, we'll give a break. Next one. See the fire in the sky? Chemtrails. This is actually flames in here. It did so much damage. The numbers say 500 people injured. Others say 1,100 people injured. Hit close to a zinc factory. Did a lot of damage. It took down all their telecommunications for quite some time. Massive, massive, massive explosion. So strewn field of it. How does it play? Yeah, here. It's supposed to play automatically. Into the video. It worked earlier. You guys want to see the video? Yeah. That's pretty cool. I like it too. Going to the member stick. So you can just leave that where it's at. My computers or my computer on it. If it was a Mac, we wouldn't have that problem. Removable disk G there. And then meteorite column. meteorite top up top. And then the Chelyabinsk. There you go.
Give me this.
Yeah, there you go. Imagine that coming at you while you're driving home. They probably thought they were under war. They think somebody was attacking them. You actually can hear, there's a lot of different videos. Some of them were just so long I didn't want to bore you to death. But some of them you hear the multiple explosions one after another. You know, 6, 7 of them in turn, and bits and pieces of that were exploding. The reason why we haven't found big pieces of it is because it literally just disintegrated.
Oh, now it's closer.
Now you've got it. All right, we'll flip through that. There we go. Simchan, Russia. So again, Russia is a hot spot for meteorites. 9% nickel, some of the highest of all of them. This was found June 1967, 380 kilograms. Again, these are huge meteorites. That Chelyabinsk piece, it'd be curious to see if it is ever estimated how big the piece really was that was coming in. But you saw from the video, it was huge. Nice little end cut of a Simchan. So this is interesting. This shows the Widmanstatten and also the olivine, all in one, and another one down here. I like those the best. I think they're the most unique. And I actually have a sphere that I brought it's obviously been cut into the sphere, but you don't see them very often because when you shape them into a sphere, the crystals fall out. Brenham, Kansas. This was a farmer plowing his yard. Clank. Thought to have fell 20,000 years ago. 4.3 tons is the total weight on the sky. The big palestite that I have there is a Brenham, Kansas. Just like that. That piece. That's one of the Meteorite Hunter guys that have the TV show. Anybody watch that show?
Yeah.
It is, Meteorite Men. It's entertaining, but they basically take a map of a strewn field and they go back to where everybody's already found them and they just find the fragments of them. But they're actually they are entertaining. Henbury, Australia. Nice little crater on that guy. 1899 it was found. They think it was probably witnessed by the Aborigines 5,000 years ago. There's no written documents on that, but that's what they are surmising. Total no weight, 1,200 kilos. 13 craters, the largest is 180 meters in diameter.
So, I'm sorry, how do they know what the weight is? And is it of one piece, or is it?
It would be
estimated
of the whole.
All the pieces?
All the pieces. And some of those are maybe not known. You know, you can go to say Henbury, and you could still dig where people have dug for hundreds of years, whatever, and still find fragments of it. So, with technology of today, we're able to find a lot of the fragments we couldn't find years ago. That's quite the nice find right there. We have a little Henbury for you to see tonight. Some of the pieces. Nantan, China. It was a witness fall in 1516. This was one that supposedly hit a cow in a pasture. And that's how hamburger was invented. Total load weight, 9,500 kilograms. Nantan, China pieces is from a very humid area. These meteorites, almost 100% of them will disintegrate on you. So again, you have to be very careful. You have to bake them. You have to stabilize them any way that you can so that they don't fall to pieces on you. It's a big piece of it. Others, again, the Widmanstatten. So you see how different the pattern is compared to the others? Thank you. For you to look at, and it only came 238,900 miles here for you.
Say, John, could you get the other lights over there, Mr. Willock?
Yep.
Hit the top button on the light switch. Yeah.
Questions?
Can you maybe a little bit about the solar forming, the solar nebula you spoke about?
It'd be the primitive formation of the solar system. Is that what you're asking? Yeah. Yes.
So, Doug, what would be the holy grail for you at this point?
We have a pretty good grail over there.
Oh, good.
Yeah, there's probably $250,000 worth of meteorites on that table. That's why we have Joe and Kelly and Sarah. Because if they get sticky fingers and I still love them. The Holy Grail, you know, anything lunar, Martian is extremely rare. We make it look easy, but it truly is very, very rare. Your rarest diamond known to exist isn't as rare as those meteorites. You know, people pay hundreds of millions of dollars for a diamond, and these really are that much rarer. I love them all. You know, I wear a saber-toothed tiger. This was a Sikhote-Alin meteorite that I had cut into a saber-toothed tiger. I just love them. You know, I find a little fragment, I get excited. So they're all the Holy Grail. Yes.
So how do you find them, or collectors find them, you're trading them? How does
Your
that work?
most experienced meteorite hunters can go years and years and years without finding a meteorite. So, with that being said, it's extremely difficult. So that's why 99% of what people bring us turn out not to be meteorites, because they are that rare. Think of that, only 5 or 6 a year ever land on Earth to where we can find them. So, very, very rare. And when they do, they're broken up into little pieces, they're embedded in the ground, they're in places that you can't even get to. Yes, sir?
How do you determine the date of the fall if it's not witnessed?
They do all kinds of isotope readings, radio spectrometry, I think it is, and they look at the craters, they look at erosion. They use a lot of different techniques to figure that out. Are we off a couple 100,000 years on some of them? Probably so. But today, it's the best we can do. Yes?
When a meteorite has so much iron in it, is it attracted to some particular spot out of orbit that has magnetism?
At 25,000 to 160,000 miles an hour, it is sheer luck of where it's going to land. Big land masses, you know, Russia, I make jokes about Russia getting hit so much just because it's so big. Africa, you find a lot of meteorites in barren land. Why is that? They're easier to see. That's the only reason you find them, is because they're easier to see. You can sit like those kids were and dig through, and you can find them. But if you're in a populated area, and they do, there was one that landed in a dental office, there was one that landed in the back of a car. They do hit populated areas. We've just been lucky. I mean, I'll go back to the Chelyabinsk again. Nobody realizes how lucky we all really were. You know, they're saying that the dust from that meteorite has already circumnavigated the Earth. We've already had some of that dust in our lungs. Think about that. And that didn't even impact the ground. So we were really, really lucky.
May I ask one more question to that? We've had comments and news articles saying that if an asteroid were to be looking as though it's going to hit the Earth, that they would use our armament to blow it apart. Doesn't look to me like it's going to be.
Sounds like a movie. But did you hear in the video they're talking about fighter jets were sent to intercept the meteorite? Is there a fighter jet that can, even if it's doing 25,000 miles an hour, is it even conceivable they can catch that meteorite?
Well, yeah, on.
The jet would be gone. Yeah, he's never known. So chances are good. I mean, if it's a really big, with technology of today, I can't even imagine that it's possible. I can't even imagine it. You know, you're talking material that is so dense. You know, when the one that explodes is like 20 Hiroshimas, what would you have to use to destroy it? I don't think you can. And the dinosaurs are gone, so maybe, you know, they're a good history for us, and there's no way we're it. No,
Why are
but
we spending money on
you know what? Because maybe technology 100 years from now, 20 years from now is capable of doing it. With the lasers the way they are, maybe they can do it. But, you know, if you watch the movies and the theory makes sense, you drill a hole into the asteroid or the comet or whatever, you put a bomb in, then it just breaks it up into multiple pieces. Well, that doesn't do you any good. Then you got multiple pieces coming at you. So, I don't know.
I thought they were just talking about nudging it a little.
Diverting it,
Not trying to.
What kind of nudge would you have to do? I mean, to knock it out of its trajectory with it traveling like that?
We're not done here quite yet, though getting close. Just a couple of things really quick. The library is officially closed. You cannot go back out through those glass doors. There's a door in the back of the lobby out here, and there are 2 doors here. You're welcome to use those. A couple other things real quick. As we break up here in just a few minutes, it would be really appreciated if you would pick up a chair and put it on one side of the room or the other here against the wall of the curtains. In 2 weeks' time, there'll be another talk here at our usual time of 6 p.m. And there's information outside about upcoming program. You're welcome to pick some of that up. If you'd like to be on our email distribution list, there's a sheet out there. Please just give us your email very, very clearly. And Doug's got an incredible selection of stuff here. We don't have too much time, but I'd like to give you a chance to take a look at what he's got here. And more than that, I'd like to have you ask you to join me in thanking Doug for this great presentation.
And you're all welcome to come to our gallery.
The gallery, yeah.
It's in Town Square next to Haagen-Dazs, below Stony Grill.